I got a really cool video of fiberglass where I had the light on it and it was in the dark, and I turned the light off and you see straight through it.
Yeah,
you
exactly.
Want to talk about that?
No, that's just when what he's talking about is how the light went all the way through the fiberglass. Well, that's a very good way of looking at how does solar heat get through that insulation. They're both electromagnetic waves. So if light goes through it, then like heat from the sun's going to go through, which R value doesn't tell us. Everybody talks about R value, R value, R value. It's all that matters. Well, it doesn't. It's 1/3 of the story. It's heat moving through an object, conductive heat transfer. Well, you don't get hot from a campfire. You don't get hot from the sun by conductive heat transfer. You get hot because of the rays coming off the sun, the electromagnetic waves coming off of that campfire. So insulation, R value doesn't tell you how well it stops that. So you can use a light to try to test it. So if you put a light in all your insulations, if it stops the light, then it's going to stop heat from the sun a lot better. And then vice versa, like in the wintertime, when this house is sitting here and the cold wind's blowing on this house, that's called convective heat loss. All right, R value tells us nothing about how well does it stop convective heat loss, how well does it stop air. So that's what's going to be really important in the wintertime, is when this wind hits this house, is it's pulling out the inside air, the heated air, out with it. Kind of like when you get a hot piece of food, what's the first thing you do? You blow on it to get rid of the heat. Well, that's what's happening to this house in the wintertime. Nice and warm on the inside, cold air rushing around all the edges, it's pulling that heat out with it. Well, if you got an insulation that stops air, then you don't have to worry about that. Which does R value tell us anything about that? It doesn't.